All right. 9.2. This is going to include some review of trigonometry. So, hopefully you remember from last year our mnemonic SOHCAHTOA. And when I was in school, there was some stupid story about some, I don't know, some great chief who was named SOHCAHTOA. I never understood it. But somebody told me a way to remember SOHCAHTOA, and I've never forgotten it, and neither will you. Okay? SOHCAHTOA can be remembered by some old hippie caught another hippie tripping on acid. Are you an old hippie? You're a young hippie. Oh. So what does this mean? It means the sine of theta is the opposite side divided by the hypotenuse. That's where the old hippie comes from. And the cosine of theta is the adjacent over the hypotenuse, which is where the another hippie. And then tangent of theta is the opposite divided by the adjacent. So if this is theta, then this side is referred to as opposite, and this side is referred to as no, it's not. Adjacent and hypotenuse. And when you're dealing in right triangle trig, you have to choose the base angles as your theta. You can't choose the right angle. If you do, then you end up with two adjacents, and then the O and the H are the same side, and everything falls apart. Now we can do trigonometry on right angles and even triangles that don't contain right angles, but for now we're going to stick with SOHCAHTOA. So question 1, what is the tangent of B? So here's angle B, would be O over A, 15 over 8. What is the sine of B? That would be O divided by H, 15 over 7. Just type in the fraction. So this would be 15 over 17. And what is the cosine of B? 8 over 17. Now if I switch to angle A, then the O and the A flip sides. So the tangent of A is going to be 8 over 15. Easy enough to remember, I hope. Okay. Here we want to find the values. So I pull up my calculator, and I need to make sure that I'm in degrees. So if you have one of these calculators and you push mode, we need to go down to degrees. If you have one of the blue calculators, it should say DEG at the bottom. If it doesn't say DEG, then there is a button right next to second, DRG, degrees, radians, and gradients. So you just push DRG until it says DEG for degrees. Okay. And I just type in the tangent of 47, and I get 1.07. Now what does that mean? The tangent of 47 is one. Let's do a different one though. That's not a very good number. Let's say the sine of 14, and I get 0.24. So the sine of 14 is 0.24. What does that mean? Well, it means that my O side divided by my H side is 0.24. So if I draw a triangle, and here is 14 degrees, I know that whatever this length is going to be 24% of H. Does that make sense? So anytime you have a 14-degree angle, regardless of the size of your triangle, your O side is going to be about a quarter of the length of your H side. So if this was 100, then this would be 24. If this was 10, then this would be 2.4. If this was 5, then this side would be 24% of 5, which is going to be 1.2. So those ratios are linked to the angles. If we change the angles, then we change the ratios. And that's what trigonometry does. It compares the two side lengths to an angle. And each of those ratios has a name. So people sometimes ask, what does the sine function do? Well, it takes an angle and spits out a ratio. So anytime you're dealing with a 14-degree angle, the ratio of the O side divided by the H side is going to be about 24%. All right. Next up, Pythagorean theorem. Hopefully this is a review. 40 squared plus 9 squared equals x squared. So that's 1600 plus 81 equals x squared. So 1681, we take the square root. So the square root of 1681 is 41. Okay, and technically it's plus or minus 1681, but can this length be negative? No, it can't. Okay, what if this was 13 and this was 12? And this was x, or y, I guess. So x squared plus 12 squared equals 13 squared. So x squared plus 144 equals 169. So x squared equals, subtract that over, and I get 25. Take the square root, so x would be 5. When I was in college, there was a science journal that published the greatest discovery of all time. The top 10 greatest discoveries of all time. You know, things like electricity and relativity, all sorts of things. And number one on their list was the Pythagorean theorem. Not because everybody uses the Pythagorean theorem, but their explanation was the Pythagorean theorem was the first time that people said, whoa, something's going on here. And they started studying mathematics. So they said that the Pythagorean theorem was the first great discovery that caused humans to decide there's more to the universe than what meets the eye. And they started trying to figure out mathematics, and that led to all of the other famous scientific discoveries. So, anyway. As Reese likes to say, fun fact. Yeah. I don't know what's so fun about it, though. Okay, we just solved a question like this. Okay. So how do we use trig to find x in this case? Well, if I call 61 theta, what two sides am I dealing with? This is opposite, and this is adjacent. Which trig ratio uses O and A? Tangent. Right? SOHCAHTOA. So we write the tangent of 61 equals 10 over x. Now, here's how we solve for x, the long way. You could multiply this side by x and multiply this side by x, and those cancel. And then you have x tangent of 61 equals 10, and then we divide by the tangent of 61. And I get x equals 10 over the tangent of 61. Another way to solve it would be to cross multiply. So we cross multiply, and I get 10 equals x tangent of 61, and then we divide by the tangent of 61. Okay? In both cases, I get x equals 10 over tangent 61. Here's the shortcut. If the variable's on the bottom, then just switch those. And we get 10 over tangent 61. Okay? Let's say that I had a 5 here. What trig ratio should we use? Cosine. We're looking for A and we have H. So the cosine of 61 is x over 5. How do I get x by itself? Just multiply by 5. And then I'd plug that in my calculator. 5 cosine of 61. So every time you do a right triangle trig problem where you're finding a missing side, it's either going to be a multiply or a switch problem. Every time. Okay? So what if I was solving that? Which trig ratio would I pick? Sine. So the sine of 61 is 10 over x. Is that a multiply or a switch problem? Switch. So x equals 10 over the sine of 61. Got it? Okay. All right, same thing here. Here we have a house. A ladder is leaning against the house. And we have a 62-degree angle of elevation created where the ladder and the ground meet. And the base of the ladder is 16 feet from the house. Which trig ratio am I going to choose? Cosine. So the cosine of 62 is x over 16. Is that a multiply or a switch? Multiply. So 16 cosine of 62 is x. All right. If you are looking flat and you tilt your head back, that is going to create what we call the angle of elevation. If you tilt your head forward and start looking down, that is what we call the angle of depression. Okay? So a ramp 23 feet long rises to a platform. The bottom of the platform is 14 feet from the foot of the ramp. Find the angle of elevation. So the angle of elevation is always going to be from level rotating up. So that's why the x is here. Find the angle of elevation. Well, I know that the cosine of x is 14 over 23. So if I know the ratio is 14/23, how do I figure out the angle? Well, I sort of need to do the opposite of the cosine. So cosine takes angles and transforms them into ratios. Do we have a function that will take ratios and transform them into angles? It's called the inverse cosine. It used to be called the arc cosine, but arc cosine doesn't fit on our calculators. It's just got too many letters. So we call it inverse cosine, and we use the cosine -1 button. So all we have to do is second cosine of 14 over 23. And one cool thing about sines and cosines, if you do it backwards, you run into a problem. So if I accidentally do 23 over 14, it gives me error. Why is that? Why can the ratio not be 23 over 14? Oh, I guess you could look at it that way. Well, cosine is A over H. Can A be bigger than H? No. They can actually be the same size, which is weird. But A cannot be bigger than H in a right triangle. And can they be the same size? Kind of. We'll get to that in this chapter. All right. That's it. Get to work.